element however, yes, you're going to write this down. Because your neutrons change, your mass is going to change, okay? And I'll give you an example of that in a minute. These are isotopes. So they're atoms of the same element. Put the phones away, guys. Put the phones away. Your neutrons change, therefore your mass changes, okay? Now put the phone away. I didn't mark you absent even though you were really late. You need to get a paper out, and we're going to be doing the examples of what we're doing today. Okay, does everyone have the definition?
No, maybe no.
Okay. Let me know when we're good. Okay, and isotopes, you can have a whole trash can of M&Ms, or think of the fun size, okay? If I gave everyone a fun size pack of peanut and a fun size of plain M&Ms, and let's say I told you guys to look at how many green and how many blue you have in your bags, would all of you have the same number?
No.
No, you wouldn't, right?
Nope.
Some of you might have 1 or 2, some of you might have 3 or 4. But if we took a class average and we weighted with if we gave it a mass, if we gave each M&M a mass, we would end up with more or less the same average. Okay, and it doesn't matter if it's a fun pack or a king size or one of those big bags. Okay, that's what isotopes are. So when you look at the periodic table, that whole periodic table, that atomic mass that you have on there, it's an average of the masses that have been found. Okay? Okay, we good? Now, the moment I start putting it up there, let's get started, okay? You can always borrow one up here if we need to. Now then, the moment you walk in, we need to be ready, okay? Okay. Now, let's say you have an atom of carbon, another atom of carbon, and another atom of carbon. Usually, what's your mass for carbon? Look at your periodic table. What's your mass? What is your usual mass?
12.
12. Very good. And what's my atomic number for carbon? Here. Okay. Thank you, ma'am. And your atomic mass is 6. Your atomic number. Okay, your atomic number never changes. It's going to be 6 for all of them because your element is carbon. Remember, if that proton changes, does the element change?
No.
Yes.
Yes.
If the proton changes, your element changes because the proton is the identity of your element, okay? So the proton will never change. So I'll always have 6 as an atomic number for carbon. But let's say my mass changes to 13. And let's say my mass changes to 14 over here for this carbon. So this means I always have protons of 6 here. Proton of 6. Protons of 6. How do I get my mass? I have to add what to the protons? What's in my nucleus of my atom? How do I get my mass? Yep, it's my protons plus my neutrons, okay? So because I have 6 protons here, I have to have 6 neutrons there. That's what gives me my 12. Okay, we see that? So if I have a mass of 13 over here, my neutrons are what over here? 6 plus 6 will give me 12.
7.
Okay, 7. My bad. So 6 plus 7 gives you the 13, right? So then what's going to be my neutrons for this one if I have a mass for 14? Okay, so you see what the only thing that changes there is because of the neutrons. That's what gives you a new mass. Okay, we see that? Guys, I can't tell where you are if you don't let me know. I know it's first period. And you guys are the only class that don't speak back to me. Like, I can't tell like where you are. Are we good? Yes? Okay, so now, how do you do isotopes? Let's say we have carbon 12. This is the mass of 12. Let's say we have this 10% of the time. Okay, and let's say we have carbon 13, and that's not a negative 13, it's just a dash. Let's say we have this 50% of the time. And let's say carbon 14, we have this 40% of the time. Okay. What you're going to figure out is your isotope, your average. Okay, and your average is your AMU. That's my atomic mass unit. Okay, my average mass unit. All right, let me put this down so I can write better. Okay, so what you're going to do here is you're going to take that percent, make it into a regular number. So this is going to be 0.10 times my mass, that's 12. Okay, go ahead and grab a calculator. And how much is that? Is how much? How much is that? 0.10 times 12? 1.2. Very good. Okay. Okay, so now you're going to do the same thing to the next carbon. You're going to move the decimal twice. So 0.50 times 13. What's my answer there?
6.5.
Very good. So you have 6.5. Okay, now we're going to do the same thing to the third one. It doesn't matter if you have 2 atoms or 8 atoms. You're going to do the same thing to all of them. You move the decimal twice, so 0.40 times 14. How much is that? It's 5.6. Okay, so now you're going to get all of them. You're going to get the 1.2 plus the 6.5 plus the 5.6. This will give you your average mass unit. And that's your total answer. Okay, so what's my total answer here? What's my AMU?
13.3.
Yep, 13.3. Okay, and that's it. That's my answer. Okay, you're getting your total average. Okay, and it doesn't matter. You can have 2 atoms, you can have 8 atoms, you can have a total of 10 atoms. Okay? Are we good? Where do we have a question? Okay, look at your worksheet and look at this front one. Pick one of these. Pick one of these and let's do that together.
4.
Number 4. Okay, so you have 99% of hydrogen 1. You have 0.8% of hydrogen 2. You have 0.2% of hydrogen 3. Okay? So remember, your first step is to change that percent to a decimal. Okay? So you're going to move it twice. 1, 2. So my answer is 0.99, and then times my mass. What's my mass for this one? It's just 1. Okay, so let's do that first. Over here also, I have 0.8. And I always get, ma'am, well, it's already not a whole number. Do I still move it twice? Yes, because it's a percent. So you're going to move it 1, 2. So I'm going to have 0.008 times what is my mass there?
2.
It's 2. And then for the third one, again, you're going to move the decimal twice. So it's 0.002 times, what's my mass there? Okay, so now you're going to multiply all of them. 0.99 times 1 is going to give you what? It's still 0.99. Very good. 0.008 times the 2 is how much? Very good, 0.016. And then 0.002 times your 3, 0.006. Very good. Now your last step is to do what? To add them all up. So you're going to add the 0.99 plus your 0.016 plus your 0.006, and that's going to equal what? 1.012. And this is your average mass unit. Mijo, do you have a pass from the VPO?
No.
And a periodic table also if you don't have one. Okay. And let's unplug, okay? Everything in your pocket. Okay, where are we stuck? Where do we need help? We good? Okay, you can get started if you want to. Okay, anyone need an extra example? No? Yes? We need another. Okay, pick another one, and I'll do it with you. Number 6. Okay, let's do number 6. So you have 98%, and your carbon has a weight of 12. And then you have a 2%, and your carbon is 14. Okay? Now remember, your first step is to make it a regular number instead of a percent. So you're going to change the percent by moving it twice. So I have 0.98, and then you're going to multiply it times your mass. What's my mass for that carbon? 12. Okay, so now do the next one. Move the decimal for the next one and tell me what that is. What's going to be my next one? Point what? It's going to be 0.02, right? And then you're going to multiply times what?
14.
Because that's my mass, right? You see how they're giving you the mass? They might give it to you on the side, or they might give it to you on the top of the left-hand corner of the element. Okay, so now what's your next step? What are you going to do? You're going to multiply this, right? 0.98 times your 12. What do you get for that? What's your answer? For 0.98 times 12, how much is that?
11.76.
Yes, it is. 11.76. Very good. Okay, so now do the second one. The 0.02 times the 14. What's your answer for that one?
0.28.
Yep, 0.28. Okay, so what's my last step?
Add them.
You're going to add them to get your total AMU. Okay, so what's my total here? What's my total for this one? What's my total? Add them up. If you add up 11.76 plus the 0.28, how much is that? Yes, it is. That's it. Okay. All right, we got it?
Yes.
Yes? Okay.